Hey, good morning, 7th grade. So sorry I'm not here in person, but I do get to use Swivl to record my lesson this morning. And just a couple of reminders for housekeeping. The homework that was assigned yesterday is due on Monday, and the homework that I assigned today is also due on Monday. So just make sure that you get all that done by Monday, and don't wait till the last day to do it, because it will be overwhelming or even hard to do. So I want us to start on page 568, and we're talking about triangles, 11-4. And I'm going to write a little bit lower because I see that little glare right here, so I'm going to try to avoid it. So 11-4, we're talking triangles. And Mrs. Woodlock, you feel free to pause at any time. If the kids need to write notes down or want to go back, I'll try to give prompts of when to pause if needed. So hopefully we can get that done. But we're on page 568. We're talking about triangles. And this will review what we know about our different types of angles, types of lines, and all that. So hopefully we'll be able to get that nailed down. So first of all, what is a triangle? A triangle... And you're thinking, Mr. A, really? What's a triangle? Well, we want to get a geometric definition of triangle, not just drawing a triangle or identifying a triangle. So a triangle is a three-sided polygon. And we're going to talk more about polygons because most of you have heard that word. You're probably good at identifying them. But a triangle is really the first type of polygon, three-sided. And it's made up of three, right? That magic word three, line segments. And then not only is it made up of line segments, remember parts of a line, but those three line segments have three vertices. That's the plural of vertex. So where two lines or line segments meet, you can call that a vertex. And so a triangle has three line segments and three vertices. So I hope we get that down there. All right. What I want you guys to do, and I'm actually going to do it on my whiteboard, and I hope you guys can see it, is I want you guys using your protractor, which hopefully, well, I'll leave some here if you don't have it, to draw me a nice triangle. But remember, guys, you don't have to draw it exactly like mine, but I do want you to write it as big enough so that you can measure some of the angles with your protractor. So I'm going to draw my triangle here, and I'm just going to draw it like this. Okay, so that's my triangle, and you don't have to draw it just like this. You do not have to draw it this way. It could be any triangle, but just make it big enough so you can measure each of these angles. All right, I have right here 1, 2, 3 vertices. And I'll let you guys have some time to draw. You can pause the video now just to get that triangle. Again, it doesn't have to look like mine, but go ahead and when you draw it, you can label your vertices A, B, and C. So go ahead and pause. Okay, so I paused, which I don't have to. But, okay, you have your triangle, and you labeled your vertices A, B, and C. How many line segments are making up this triangle? Yeah, 3. And how many vertices? 3. So that's my triangle, and it's a polygon because it's not an open figure. There's no gaps in here. Okay, what I want you guys to start off doing with your protractor is to measure angle A. I want you to tell me what the measure of angle A is with your protractor. And then if you get done early, if you could try angle B and angle C as well, I want you to write those numbers down. So you're going to put the measure of angle A is equal to whatever. The measure of angle B is equal to whatever. And the measure of angle C is equal to whatever. Now, I'm not only testing you on how to draw a triangle, but I want to see how your protractor skills are doing. So go ahead and figure that out. You can pause the video again and let the students figure out what those measures are. Okay, so you get your measures here, And I'm going to estimate, I'm going to go with 30 for mine, angle A. B, I'm going to go with, that looks like a 120 maybe. And then angle C, I'm going to go with 30 again. Okay, now I'm pretending I measured my angles, but I didn't. I'm just estimating here. And obviously angle A and angle C are very close, but I don't think they're the same. This is for illustration's sake. You're going to notice something about these numbers. Can you go ahead and do something for me? Can you add your three numbers together? And when I add my numbers together, I get 180 degrees. That's what my sum is. Go ahead and find your sum. If you need to pause the video, you can now. Okay, so how many of you got about 180 degrees on that? How many of you got 180 degrees? All right, some of you did. How many of you got pretty close to it? Obviously, I think some of you did, maybe really, really close, but not exactly 180. And if you got far off of it, like you're way off, you got 190, 170, something beyond that, that probably means something was not measured correctly, because I'm guessing all your triangles were good. It's just the measuring of our angles maybe have been off. Maybe it was off, okay? So you should get 180 degrees. And here's a key fact about triangles. Every single real triangle has three angles, and the sum of those three angles is always 180 degrees. Always, always, always. And by the way, guys, on your homework, I'm going to see if you really understand that. It's always 180 degrees. And speaking of your homework, just to kind of give you a variety or a problem that you might encounter, let's say I have the same triangle, same measurements, but then I do this. Ready? I don't know what angle B is. How in the world can I find it? How in the world can I find the measure of angle B without a protractor? So obviously you could just measure it and figure it out, but how do I do it without the protractor? And that's what you're going to be asked to do on your homework. So let me give you a little bit of time to think of an idea of how to do that. So talk with your neighbor, the person next to you, and pause it for just a few moments on that. The way you find out that missing angle is to add the two known angles, so 30 plus 60, or excuse me, 30 plus 30 is 60, and you're like, okay, what does that do for me? Well, I have two out of the three parts. I add the two parts together that I know, and what do you think I do with the 180 and the 160? And I hope you've talked it over and you figured out that it is, you subtract these two and you get your 120 degrees, and that would be the measure of angle B. So you can do that with any triangle, whether it's drawn, maybe like this, or if they just give you the angle measurements. So that is something you're going to have to do on your homework. Don't forget, the three angles in a triangle always have to be, oh, I heard that. Is it 180 that you said? Okay, I hope that was it. Okay, let's move on. Example number one, just to make sure you guys get this, I want you to work on your own, but don't look at the answer because obviously the answer is there. They gave me angle CAT, and they gave me two angle measurements. They gave me angle C is 47 degrees, and angle A is 59 degrees. And what do you think they're looking for in this problem? They want to know what is angle T's measurement. I don't know. So how do you guys think I should find it? Oh, so we'll come back. Okay, so I have angle C, and sorry about that glare. I hope you can see angle C. Example one, by the way. Angle A is 59, and angle T I don't know. So go ahead and take a little bit of time to figure that out. Hint, we did it right here. Okay, so hopefully you can get that down. So go ahead and pause. Okay, so how do you find that angle T, that missing angle, that third angle? Well, I do know two angles, and I know 47 plus 59 hopefully you thought of, maybe I should add those together because I know those. I get my 106, because I carried that one. Okay, I have 106. What do I do with 106 degrees? Well, I know that all three angles add up to be what? 180. So what do I do with 106 and 180? I should subtract. So when I subtract, I get my 74 degrees. So what should the measure of angle T be? Hopefully you got 74 degrees, which was the answer on that one. Okay, that's most of your problems. I did also give you one problem that deals with this type of, with example 2 basically, and it is a bit tough because they don't give you any of the angles. They only give you a ratio. Example number 2, please. Example 2, the measures of the angles of a certain triangle are in the ratio 2, 3, 4. So they give me this ratio right here. And then they say, find the measure of each angle. Man, that's kind of cruel actually, because did they give you any of the angles? No, they gave you a ratio. They gave you, and again, it's hard to see, 2, 3, 4. So what do I do with that? Let's talk about what we already know. How many angles are in a triangle? 3. What do we know about the sum of those angles? They add up to be 180 degrees. And guys, you notice I keep saying 180 degrees for the 3 angles added together. Do you think that's important? Of course you do, because you're good students. Okay, so I look at these 3 numbers in this ratio, and I'm thinking to myself, I see a little bit. Maybe I see something. Notice you have 3 numbers that are being compared. Remember, a ratio, 2 or more numbers being compared. So here we go. Can you guys kind of follow me? How many numbers do I have? 3. How many angles do I have? 3. Do you think these numbers relate to those angles some way? It's possible. But they still didn't give me much on this problem. All right. There is an explanation for it, and I want to go into more detail in person because I want to get your questions. But even though they don't give me an actual number, they do give me this ratio, which is enough. I know that this big angle, right, the 4 would represent the biggest angle. This angle would be twice as big as the smallest angle, right? And then this middle angle, or this middle-sized angle, would be in between the smallest and the largest. Okay, so I know some things about these angles. So this is what I do. I use this ratio and I set up an equation. 2x plus 3x plus 4x. And you're like, where in the world did you get the x's? They didn't give that to me in the problem. And they didn't. But I know that these relate in a certain way. That certain way is x. Okay? It's an unknown. I don't know it. If I knew it, this problem would be easy. But they gave me a little bit of a curveball. So all I did was I wrote that ratio and put with each number in x, and now I'm adding it. And does anyone know, and I've been asking this a lot now, so hopefully you get this down, what these 3 angles have to equal? 180 degrees. So they have to equal 180 degrees. So you're like, okay, great, that doesn't do much for me. Well, I actually did enough for you to solve this problem. Okay, I have 3 terms. Do you guys know anything about those 3 terms? They are like. Okay, good. This reminds me of a recording like people do on TV where they wait for the kids the answer. So, sorry, this is kind of a tangent thing. How many of you are familiar with like Blue's Clues, Nickelodeon, Blue's Clues? I remember my sister watching it, and sometimes I'd have to watch it with her because I had a babysitter. So she's watching it, and I remember the host, he would say, all right, kids, what do you do when you add these up together, for example? What do you do when you add 2x, 3x, and 4x? And he does this awkward pause and waits for the kids to respond. That's what I feel like, but hopefully you can forgive me for that. But what is 2x plus 3x plus 4x? It would give me 9x, right? These are 3 like terms. They give me 9x. So now I have 9x equals 180 degrees. Do you know how to solve for this equation? Hopefully you do. X, I want to get it by itself, so I should divide by 9. And what is 180 divided by 9? 20. Yay, I got my answer. That's actually not my answer. My answer, or my question was, what are the 3 angles? But I want to tell you right now, you don't have one of them yet. You only have x equals 20. You're like, what do you mean, Mr. A? Well, here's what we have. The first angle is 2x. The second angle is 3x. The third angle is 4x. So is x one of the angles? No. But 2x was one of the angles. What's 2 times 20? 40 degrees. That is my first angle right there. My second angle is 3x. What's 3 times 20? 60 degrees. That's my second angle. And my third angle was 4x. So what's 4 times 20? 80 degrees. Okay? You're like, okay, are you really sure about that? Here's a great check. What's 40 plus 60 plus 80? Well, what should all the angles in a triangle equal? 180 degrees. These right here are my answers. 40 degrees, 60 degrees, 80 degrees. Again, I'll talk more about the explanation on that, but you have one problem that deals with it. Use this info to help you with that. They'll give you a different ratio, but you can use the same process to figure out what x is and then what each angle is. Okay, last thing I want to do, and this will be hopefully kind of quick, is I want to deal with the classification of angles, or triangles. Okay, triangles are not all the same. In fact, some of you drew your triangle way different than mine, and that's okay. It's still a triangle. But we want to classify triangles by their angles. By their angles. So there are 3 triangles according to their, 3 types of triangles according to angles. The first one I want to get is an acute triangle. Okay, we're talking again about acute triangle, not acute angle necessarily. Okay, acute triangle. Okay, an acute triangle is a triangle that has 3 acute angles. 3 acute angles. Okay, so can you do me a favor? Maybe in your notes somewhere, can you draw me an acute triangle? It could be small, just a little sketch. You're like, how do I do that? Well, just draw a triangle where all 3 angles are less than 90 degrees. So all of them have to be less than 90 degrees. So here, less than 90 degrees, less than 90 degrees, less than 90 degrees, that's an acute triangle. The second type of triangle, according to its angles, is an, what do you think? Obtuse. An obtuse triangle. What's an obtuse triangle? The definition geometrically has one obtuse angle. And I'll put that sign right. Remember our angle? Remember our angle? Okay, so one obtuse angle. So draw me a little sketch of that. And that's mine. Here's my obtuse angle. Notice that the other angles have to be acute. So an obtuse triangle has to have one obtuse angle. And I'm going to ask this question when I come back on Monday. Can a triangle have 2 obtuse angles? 2 obtuse angles. So an obtuse triangle has 1 obtuse angle, so one of the angles has to be greater than 90 degrees. Okay, that's an obtuse. And the other one, we're going to call it a right triangle. And what do you think a right triangle has? It has 1 right angle. Has 1 right angle. And sorry, Swivl, come back to me. Has 1 right angle. So if I draw one, it has to have 1 right angle in that triangle. Okay? That's classifying by its angles. I'm going to kind of pause it right here, let you guys look at it, take notes. If you want to pause the video, you can to get these notes down. Okay, Now we're going to finish off with classifying by, not by the angles, but this time by the, maybe you guys can say it before I write it, sides. I'm going to classify a triangle by its sides. The first one I want to deal with is an equilateral triangle. Equilateral triangle. And does anyone have maybe a guess of what equilateral means? Equilateral. Lateral. Sides. Equal sides. So 3 equal sides. 3 equal sides. 3 equal sides. Sorry about the video. I think every time I turn around it kind of throws it off. But here we go. 3 equal sides. Okay? And an example of that would be that. Do you guys remember what these little tick marks mean? When I draw these tick marks on the side or on the angle, that means that this side, and that side are equal or congruent. Okay? The second type we want to look at, the bell just rung, so everyone's going to come in now. This is a tough word. Isosceles. Isosceles. That's a strange word, but go ahead and write isosceles. And that means at least, if you guys can wait just a moment, 2 equal sides. 2 equal sides. Can you close that door? Thank you. At least 2 equal sides. So technically an equilateral triangle is also isosceles, but not all isosceles are equilateral. I hope you can see that by the word at least. And an example of that would be, what am I saying with those two little tick marks on the 2 sides? That 2 of the sides are equal, not that third one in this case. And then the last one is going to be called scalene. Scalene triangle by its sides. Scalene triangle. Okay, 3 equal sides, at least 2 equal sides. Scalene might mean no equal sides. No equal sides. So it's kind of like the odd duck. No equal sides. So one of them would be like that. None of these are equal. So that would be called a scalene triangle. Okay? Go ahead. I'm going to pause it right here real quick. Get your notes down. Draw a sketch of each triangle. And then I'm going to give the homework on the next screen. Remember, when's this homework going to be due? Monday. So you have 2 assignments due on Monday. I'm kind of sorry, but kind of not because I'm giving you extra days. But hopefully you don't wait till the last minute. Okay, your homework tonight, or this weekend, is going to be numbers 12 through 28. I'm going to change just a little bit. 12 through 28 even. I'm going to give you evens today. And that's page 570 and 571. 570 and 571. Okay, so again, it's numbers 12 through 28 even, pages 570, 571, and that's going to be due on Monday. Okay, guys, sorry I couldn't be there today. I hope the video helps. I don't mind you working with the person next to you, but let's not make it like where we're calling out things and talking across the room. Just talk with the person next to you if you have questions, and hopefully the video helped enough with that. I have my students waiting to come in, so I better get going. All right, see you guys. I'll see you on Monday if I don't see you today.